Hey guys, today I want to show you how to use unit rates as a fifth ratio problem strategy. We have used four different ratio problem strategies: tape diagram, double number line, coordinate plane, and proportions. And unit rates can help you solve ratio problems that don't even involve unit rates as possibly a fifth strategy. So I want to show you that today. So after you've written this down as your title in your notebook, mark your page, close it up, and unpause. So here's the strategies we've done so far: double number line, tape diagram, proportion, coordinate plane. These, different ones seem to work better on different problems. And so I kind of want to add a fifth possibility for the mix. If if some of these are still tough for you, I want to show you a neat way. I'm going to bring back some problems we've already done and show you how to use a unit rate to solve some of these sometimes in a fancy way. So let's bring this one back. Brookwood basketball games, the ratio of students to total fans seems to stay the same. If next week's game has 161 total fans, how many would you expect to be students? So you probably remember that problem pretty well. So we've solved this with several other methods. Let me show you how to do this with a unit rate. Even though this is not a unit rate problem, it's asking me for 161 total fans. That's in here somewhere. 161 total fans is going to be somewhere between 20 and 25 students. It's not a unit rate problem, but I want to use a unit rate to do it. Here's what I'm going to do. So I can pick any one of these as my starting point for when I use the proportion. So just say we can, a simple one, the number, it's 5 students for every 35 fans. And so what I'm going to do is I'm first going to turn that into a unit rate. I'm going to go down 1 student, since that's dividing by 5. Then I'm going to divide that by 5. And so that's a 7-to-1 ratio. Anytime there are 7 fans, one of them is a student. That's my ratio. And now that I have that unit ratio, it's super easy to jump up to this. So now I'm just going to say, oh, okay, well, then for 161 fans, that's times 161 divided by 7. That's times 23. And since I have that unit rate, it's very easy to multiply that numerator by 23 and get 23 fans. Or 23 students, I'm sorry. So pretty simple. By switching to a unit rate in the middle here, it's very easy then to solve the problem from the unit rate. That's kind of how the strategy works. It's sort of like, well, if I do that first, then it's no problem to jump to the answer. Let's do one together. All right, another problem you have done. In a triathlon race, athletes complete bike and running miles in a ratio of 5-to-3. If a triathlon is 28 miles, how many miles of each does the athlete do? So remember, this is a part-to-part, and we're given a whole, so we need to think part-to-whole ratios. So the part-to-whole, that's 5 bike to 28 total. And I guess the other problem is 3 run to 28 total. Oh, and I'm sorry, that's not how you want to set that up. So the whole would be 5 bike and 3 run. So that would be 5 bike for every 8 miles. And you would run 3 for every 8 total. That's my part to whole. Sorry, the 28's where I'm going. So 5 to 8 and 3 to 8. So what I would do is I would say, okay, well, let's just change that to a unit rate first. It doesn't matter particularly if you go put the 1 here or the 1 here. Kind of makes more sense to me to probably do it up here. So for every mile that I bike, I am doing a total of 8 divided by 5. 1 6/10 total miles. So every time I bike a mile, I'm doing this many total miles. And so now from there, when I jump to my 28, I will, let's see, so that is times what? Times 28 divided by 1 6/10. 17.5. And it's obviously, it's super easy then. I don't even hardly have to do the math on my numerator to know that it's going to be 17.5 bike miles for every 28 miles. I set up here, it didn't really matter if you made the denominator the 1 or the numerator the 1. Doesn't really matter. Why don't we just switch it this time on the bottom, since you probably already kind of have the hang of this. Why don't this time I'll just do my denominator as 1. So for every 1 mile I do total, I run 3 divided by 8, that far. 375 thousandths running miles. So that's kind of a weird ratio, but for every mile I run total, this much of it is running, and the rest of it would be biking. And so now when I jump up, so now the denominator is going to be easy, right? I know I'm going to do 28 total miles. And so it's pretty easy to figure out what I multiplied by there. So I'm just going to do that on the top. Times 28. 10.5 running miles. So, good strategy. You know, what I like about it is it's very logical. A lot of times if you forget how, let's say a few weeks from now, you forget what strategies you have, it can be very logical to just say, okay, well, I'm just going to switch to a unit rate and then figure it out from there. Works pretty easily. So there you go. That's the strategy. Hope you like it. If you understand the examples we did and you have written down your notes, hopefully a little bit neater than I did, you're ready for tomorrow. See you then.